Hello again. Sorry, I'm not quite sure what happened with the previous video. I couldn't actually tell if I was still recording or not. So anyway, we were talking about compressive strength and compressive forces, and I think I asked about a skyscraper. So think of a skyscraper and what's different about the forces it's experiencing at the bottom and the forces being experienced at the top. So what's going to be different about that? Well, the top of the skyscraper is going to be affected more by things like the wind. We saw that in the previous video. But of course, the bottom of the skyscraper is experiencing most compressive strength. It's being squashed by the force from the weight of the rest of the skyscraper. And so that might be when we start to use reinforced concrete. So in the lesson on composites, you learned that sometimes concrete is reinforced by steel posts. So that is the sort of thing they would use to counteract the compressive forces acting on a skyscraper. Okay, so just a quick reminder, you can pause and get those jotted down if you haven't done it already. And I'm going to show you now yet another example of why thinking about compressive and tensile strength is important.
Federico Olivares, the CEO of Second Skull, and Tyler Palco, former NFL quarterback and college quarterback at University of Pittsburgh. You're now the VP of this company. So, Federico, tell us how this technology works.
So it's a soft urethane that hardens upon impact, and it's really, very demonstrable. So I'll show you basically what it does.
Okay.
The soft molecules on our material harden upon impact and add the protection. So I'm going to show you, this is regular foam found in many helmets.
Okay. Yeah, I would see it bounces. Okay.
It's not absorbing the impact.
Okay, sorry, we had a problem with buffering then. Let's try that again.
The impact. And this is our product. Our product is absorbing the impact, and we've tested the product in a lot of different ways, including sports, helmets, and obviously football.
I'm going to drop this from a little bit higher. Let's see one of, defensive end chasing Tyler here. Still does it. A little bit higher.
And you can hear, if you do the same on the other one, it's going to go through and hit this piece of wood. But basically, we tested the products in the same way that new helmets are tested, following the NOXI linear impact testing.
Okay.
And we basically tested helmets on their own, helmets with Second Skull.
Tyler, what would you tell a fellow football player about this product?
Sports has taught me so much, and you don't ever want the reason for not to play be because the safety issue is not there, right? So the skull cap actually is very, very similar to any of the skull caps that are being worn by, Cam Newton, Larry Fitzgerald, any of those skull caps you wear under your helmet now.
Yeah, we're calling our Ford technology that works. Tyler Palco, Federico, congratulations on this product, and as you said, available at Dick's Sporting Goods. Guys, thanks so much.
Thank you.
Okay, so you can see from that testing that the material they designed for their skull caps actually was absorbing the energy from the ball bouncing on it. So in the same way that the skull cap would absorb energy from impact while you were wearing it. So not only are scientists understanding the properties of existing materials, but they are of course designing new materials with the desired properties. Okay, now we're going to look at how we calculate the stress on a material. There's lots and lots of maths involved in designing and testing materials. We're just going to look at one example of that now. So how do we calculate stress? Well, if you've come across pressure calculations before, this probably looks familiar because we calculate stress in the same way we calculate the pressure on a material or an object. So if we know the force that's being applied to the material, and we know the area over which that force is being applied, we simply do force divided by area, and that tells us a measure of the stress. So the units we use, newtons per metre squared for the stress. Force is measured in newtons, and area measured in metre squared. So let's just have a look at some calculations. Okay, so I'm going to talk you through how you would do the first one. Remember the equation. Oh, let's move me because I'm blocking the equation out. There we go. So stress equals force divided by area. So to calculate the stress for number one, we would take the force, which is 10 newtons, area 0.001 meters per squared. Do force divided by area, so that's 10 divided by 0.001, and that will tell us the answer for our stress, and the unit would then be newtons per metre squared. So pause the video now and have a go at those calculations. You can use a calculator. I don't expect you to do these in your head, and then we'll go through the answers. So I'm going to move on, so pause the video if you haven't finished. Okay, so for question one, you should have done 10 divided by 0.001, which gives you an answer of 10,000 newtons per metre squared. Question two, force divided by area is 20 divided by 0.002, which equals 10,000 newtons per metre squared. Question three, 10,000 divided by 0.05, which equals 200,000 newtons per metre squared. Number four, 25,000 this is the other way around, isn't it? So we have to rearrange the equation. So if stress is equal to force divided by area, then area is going to be force divided by stress. So thinking about how you rearrange your equations, on a foundation paper, this will be given to you. You won't have to rearrange this yourselves. So you need to do force divided by area, 3,000, force divided by stress, 3,000 divided by 25,000 gives you an area of 0.12 meters squared. And for this one, again, we have to rearrange the equation, but it will be given to you on the foundation paper. So if you struggled and you're doing that, don't panic. Force is stress times area. So 36,000 times 0.006 equals 216 newtons, that should say. Sorry, I didn't see that misprint there, typo. 216 newtons. Okay, we're just going to see some of the methods used to test hardness now. Don't forget to make notes on what you're seeing for these different tests. Okay, so we've got hammering a punch, or a center punch as it's called, into a material. You could of course measure the force required to make an indent in the material. Using a hand file, again, to make that more scientific, you could actually apply a load to the file and measure the load needed as you file to make indents in the material. And lastly, dropping a plug down a tube. So hopefully you've made notes on those. If you haven't, you could just rewind the video slightly, pause the video and make some notes on those techniques. Okay, that's all the information you're going to be given today. So you can pause here now to complete the plenary task.